Oh, one more thing I wanted to mention. We'll be talking about the brainwave entrainment of monaural beats later in the program. You'll understand what that means when we get to it, but we have some playing right now in the alpha frequency range, hoping that will put you in a state of calm, relaxed focus and concentration to be able to retain the information from this presentation more. Okay, let's see. So, making brainwaves. Brainwaves are also known as neural oscillations. Here we go. So the brain is an electrochemical organ, and that means that electricity is produced by the chemical changes in the brain at the neuron level. A neuron, or nerve cell, is the basic unit of the nervous system, and that's a cell that carries electrical impulses. The dendrites, here we go. So the dendrites are the branches that receive chemical messages from other neurons, which are converted into impulses. And your neurons don't actually twirl around like that in your brains, do they? Mine might, I don't know, but not yours. The soma refers to the central cell body. The axon is the trunk of the neuron that sends messages or impulses to other neurons. You can see that demonstrated by that little beam of light that's coming down. And the axon terminal contains the buds at the end of the axon from which chemical messages are sent. Then the synapses are the small gaps that separate neurons found between the axon of one neuron and the dendrites of another. So basically, they would be linked up head to tail. Brainwaves are generated by the synchronous firing of millions of neurons known as pyramidal neurons. So that's a special type of neuron that lives in your brain. They reside in the brain's cortex. They fire synchronously in what are known as neural ensembles. Because the neuron's dendrites all point in the same direction, their synchronized activity creates an electric field that can be measured from the scalp. The instrument that does this measuring is the electroencephalogram, or the EEG. So that's a diagram of how that electrical current is generated. Brainwaves share the same characteristics that all waves do and are measured by their frequency, amplitude, and phase. Here we go. These characteristics are extracted from neural recordings using time-frequency analysis to determine a person's brainwave frequency. In general, EEG signals have a broad spectral content similar to pink noise, but also reveal oscillatory activity in specific frequency bands. So these are the most common brainwave bands, and there are 5 basic brainwave oscillation patterns that I will be focusing on today. They are gamma, beta, alpha, theta, and delta. Gamma is the brainwave frequency that is the fastest, with a frequency range between 40 and 200 hertz, and these occur when different brain regions fire in harmony, such as in moments of insight. Gamma is also associated with peak concentration and high levels of cognitive functioning. Neuroscientists believe that gamma waves link information from all parts of the brain together, causing the brain to work most efficiently. So that's like a whole brain. Beta waves associated with a frequency range of 14 to 30 hertz, and hertz again are cycles per second. These are the type of brain waves generated by our brains when we are fully awake and alert. Our brains generate beta waves when we are thinking actively, problem solving, engaging in productive activity, or actively communicating with others. Beta waves in the higher frequency range also are associated with states of high alert, such as fear and agitation. Alpha waves, associated with frequency levels of 8 to 14 hertz, are the type of brainwave our brains produce when we become relaxed. So that's what we're aiming for right now. Generally speaking, alpha waves are produced when we're super calm, but very much still aware of what's going on around us. They can be associated with unwinding in a stress-free environment, after work, light meditating, or engaging other forms of quiet contemplation. Theta waves are produced when our brains begin to calm down to an even greater degree and are associated with states of reduced consciousness. Theta frequencies are covered by a range between 4 and 8 hertz. We produce these during light sleep or dozing, deep meditation, profound visualization, hypnosis-related states, and drowsiness. And delta waves are the type of waves produced when we're actually unconscious or asleep. Frequencies here range between 1 and 4 hertz. And in addition to deep regenerative sleep, this state is a key contributor to immune system function and a person's overall physical health. Next, we'll explore the ways that neurotransmitters contribute to brainwave states and ways that brainwave states lead to the release of certain neurotransmitters that produce physiological effects that are beneficial in learning, memory, and wellness. So there's a two-way thing going on there. Neurotransmitters are the chemical means of communication between the neurons that are diffusely distributed in the brain, and they are responsible for the creation of the brain waves. So you can kind of think of them as the electrical current. There are hundreds of neurohormones, neuropeptides, and neuromodulators, but a few among them are the most important and well-studied. These include dopamine, serotonin, acetylcholine, Y-aminobutyric acid, or GABA, and glutamate. There is a connection between different neurotransmitters and different regions of the brain, as well as different brainwave frequencies and regions of the brain. As far as we can tell, each brain center generates impulses at a specific frequency based on the predominant neurotransmitter it secretes. In other words, the brain's internal communication system is based on frequency. When we send in waves of electrical energy at, say, 10 hertz, certain cells in the lower brainstem will respond because they normally fire within that frequency range. The frontal lobes have dopamine in abundance, which creates the predominant beta waves of these lobes and is responsible for alertness. The main neurotransmitter of the parietal lobes is acetylcholine, which is responsible for the creation of alpha waves and determines the thought processing time and the speed at which the brain works. Temporal lobes abound in GABA, which produces theta waves and generates a natural analgesic, tranquilizing and generating a calming response in the mind. While the occipital lobes are serotonin-rich. Serotonin is converted into melatonin by the pineal gland and creates delta waves responsible for the deep sleep stages. The prefrontal lobes are rich in glutamate, which generates the gamma rhythm. These are fast brain waves involved in the highest mental activities like judgment, reasoning, abstract thinking, and finally, creating a spiritual state. Since these neurotransmitters are produced once a certain brainwave frequency range is reached, it is also desirable to affect what neurotransmitters are being produced by bringing a person into a specific brainwave frequency range. This process is known as brainwave entrainment. It's also known as neural entrainment or brainwave synchronization. So those are all the same things. Brainwave entrainment is any procedure that causes one's brainwave frequencies to synchronize with a periodic stimulus, which could be sound, vibration, or light, having a frequency corresponding to the intended brain state, for example, to induce a trance, sleep, relaxation, or focus. Brainwave entrainment was first identified through scientific tests in 1934, but brainwave entrainment has been happening for a long time. We'll talk about some examples of brainwave entrainment throughout history now. And we'll start by discussing the use of visual stimuli. Ancient scientists were fascinated by the phenomenon of flickering lights. Apuleius experimented in 125 AD with a flickering light produced by the rotation of a potter's wheel, finding that it could reveal a type of epilepsy. That's probably something that we're most familiar with through pop culture out of flickering lights and strobe lights, Hypnotoad and such. Ptolemy studied in 200 AD the phenomenon of the flickering generated by sunlight through the spokes of a spinning wheel. He noted that patterns and colors appeared in the eyes of the observer and that a feeling of euphoria could be experienced. Clinical reports of flicker stimulation appear as far back as the beginning of the 20th century. Pierre Genet, a French psychologist and psychotherapist, reported that by having his patients gaze into the flickering light produced from a spinning spoked wheel in front of a kerosene lantern, they showed a reduction in their anxiety and hysteria. Not long after the discovery of the alpha brainwave by Hans Berger in 1929, researchers found that the strength of the wave could be driven beyond its natural frequency using flickering lights. This is called photic driving, which is another word for brainwave entrainment using photic or light stimulation. In the 1930s and 1940s, scientists such as W. Gray Walter and others used powerful electronic strobe lights and the new EEG equipment to alter brainwave activity, producing trance-like states of profound relaxation and vivid imagery. Next, we'll talk about auditory stimulation. Music has long been known to have evident psychological and physiological effects on humans and to be used intentionally for that purpose. We're familiar with the term photic driving for light now, so this would be known as auditory driving. Early examples of auditory driving are seen in the drumming of indigenous peoples in Africa and the Americas. The repetitive drumming used in tribal rituals is typically a rhythmic beat close to the frequency of EEG delta and lower theta waves in the 0.8 to 5.0 hertz range. Some theorists consider the auditory driving of the theta wave to be a possible entry into an altered state of consciousness. Remember, theta waves produce calm and reduced consciousness. We produce these during light sleep or dozing, deep meditation, profound visualization, hypnosis-related states, and drowsiness. The ancient Indian system of Nada Yoga is a science of inner transformation through the power of sound. Nada, or Nad Yoga, is the conscious use of sound vibrations like chanting, mantra, and musical resonances to treat various spiritual and psychological conditions. Practitioners focus their mind in meditation and then use sound to access higher states of consciousness and healing. This meditative state is again characterized by the theta frequency range. In ancient Greece, music and medicine were also closely connected. They had the same god, Apollo. The contributions of several philosophers, mathematicians, and writers, including Aristotle, Hippocrates, Homer, Plato, and Pythagoras, were instrumental in developing the music-healing connection. These philosophers were convinced that music could be used therapeutically. This belief was put into practice when those suffering from manic episodes were treated with flute music, and those plagued with symptoms of depression were instructed to listen to dulcimer music. Ancient Greeks were even said to treat hangovers with music, the right kind. It is also important to note that ancient Greece, we know very little about their system of musical notation, so musical elements such as tempo, rhythm, and pitch remain lost to the ages as far as these therapeutic musical numbers were concerned. Some of this ancient knowledge was put to rest until the 1700s when Diogel measured physiological responses on the effects of music. He brought live musicians to his laboratory and his patients' bedsides to conduct experiments and record his findings. And he worked in a mental hospital in Paris. This is an example of probably someone who could benefit from this bedside chamber music. This is a patient who is experiencing hysteria there. His published paper in the 1800s showed that music lowers blood pressure, increases cardiac output, decreases pulse rate, and in general, assists the work of the parasympathetic system. So this tendency for the body's physiological responses to synchronize with some external stimulus is now known as the frequency following response. You may have heard other studies about how some kinds of music are beneficial for studying. By playing music pulsed at about 60 beats per minute, the frequency following response can induce alpha brainwave states. Listening to these rhythms naturally paced to our body's state of relaxation causes the breath and heartbeat to become calm and regular. the slow, largo or adagio movements of Baroque music, composed by such 17th and 18th century musicians as Vivaldi and Bach, follow the 60 beats per minute pattern that has the most powerful and relaxing effect on the mind. Other types of music with faster tempos can be used to induce beta brainwave states. And I do want to make the distinction here that this is talking about tempo and beats per minute, not wavelengths and cycles per second, which we have been talking about up to this point. So there are two paths to entrainment. There's the frequency following response, where body rhythms and pulse follow the beats per minute of the music, and the body physiological reaction affects the brain and the brain waves and neurotransmitters produced. In the other direction, brain waves can entrain to Hertz cycles, like in the photic flickering effect, and the brain affects the body and its physiological response. I also want to mention here that this is not the same theory behind the Mozart effect, which is not based on the brainwave entrainment research I'm covering in this presentation and which has been debunked, but that's for another presentation entirely. Okay, so coming into the present, we'll talk about the field of psychoacoustics. Psychoacoustics is the scientific study of how music and sound impact the nervous system psychologically and physiologically. Simply, it is how sound impacts the mind and the body. The principles of brainwave entrainment have been incorporated into experiments with sound generated to bring people into specific brainwave states through binaural, monaural, and isochronic beats. Sound has also been combined with light pulses in audio-visual entrainment. Binaural beats were first theorized in 1839 by Heinrich Wilhelm Dove, but first scientifically tested and proven in 1973 by Dr. Gerald Oster, a medical doctor and biophysicist. With binaural beats, brainwave entrainment happens inside the brain and is caused by a physiological response. Upon hearing two tones of different frequencies sent simultaneously to the left and right ears, the brain perceives a third tone based on the mathematical difference between the two frequencies. For example, if a 200 Hz sound frequency is sent to the left ear and a 200 Hz to the right ear, the brain will process these two frequencies and perceive a new frequency at 5 Hz. The brain then follows along at the new frequency of 5 Hz, producing brain waves at the same rate of Hertz. This is another example of the frequency following response mentioned previously, which is used here to entrain brainwaves directly rather than indirectly through entraining bodily responses of breathing, pulse rate, and muscle relaxation. Monaural beats are the result of mixing two separate steady tones externally, producing nearly the same sound as that of the binaural beats. The concept behind monaural beats and monaural brainwave entrainment is the same that underlies binaural beat entrainment. Two slightly different steady tones are introduced to each speaker, and the resulting sound is mixed before it reaches the ear. So the result is similar to a binaural beat, but since the produced tone is formed outside the skull, monaural beats do not require headphones to work, whereas binaural beats do. And then an isochronic tone is a single tone that turns on and off in a particular pattern matching the desired frequency. It is very effective because the tone is not heard at all during the pauses, although accompanying music may provide a background. The contrast between on and off is very high, inducing a strong neural response. In comparison with the binaural beats, where you hear a continuous sound that fluctuates in volume, you hear a sound at distinct time intervals with isochronic beats. Some people compare it to the sound of a helicopter, to give you that reference. So there we go again, internally 5 Hertz. So combining the effects of light and sound entrainment, audio-visual entrainment uses flashes of light and pulses of tones to guide the brain into various states of brainwave activity. Audio-visual entrainment devices are often termed light and sound machines or mind machines. Besides entrainment to external stimuli, there are other methods of changing one's brainwave frequencies. Meditation. One safe, simple way to alter one's own brainwaves, in both the short term and the long term, is through meditation. Meditation has roots in the contemplative practices of nearly every major religion. It can be broadly thought of as the cultivation of basic human qualities, such as a more stable and clear mind, emotional balance, a sense of caring mindfulness, and love and compassion. Studies on mindfulness meditation have shown an increase in the prevalence of alpha wave activity, not only during meditation, but also during other daily activities. Alpha waves are likely responsible for creativity and relaxation. Because alpha waves are so internally focused, they also make it easier to recognize bodily sensations such as pain or pleasure. This would explain why mindfulness meditation helps people conquer depression, anxiety, and chronic pain. By increasing the presence of these calm, self-reflective brainwaves, meditation allows people to think more clearly and soothe their own negative emotions. Another study published in 2014 in Scientific American talks about modern technologies used to offer insight into the effects of meditation. In the year 2000, the 14th Dalai Lama brought new focus to the study of connections between science and Buddhism by launching the subdiscipline of contemplative neuroscience. He did this by inviting scientists to study the brain activity of expert Buddhist meditators, defined as having more than 10,000 hours of practice. For nearly 15 years, more than 100 monastics and lay practitioners of Buddhism and a large number of beginning meditators have participated in scientific experiments at the University of Wisconsin-Madison and at least 19 other universities. Advances in neuroimaging and other technologies enabled scientists to gain insight into what happens in the brain during three major forms of Buddhist meditation: focused attention, mindfulness, and compassion and loving kindness. Focused attention meditation aims to tame and center the mind in the present moment while developing the capacity to remain vigilant to distractions. A brain scanning study at Emory University has pinpointed several distinct brain areas that become involved as attention shifts. Mindfulness, or open monitoring meditation, tries to cultivate a less emotionally reactive awareness to emotions, thoughts, and sensations occurring in the present moment to prevent them from spiraling out of control. In mindfulness, the meditator remains attentive moment by moment to any experience without focusing on anything specific. Expert meditators have diminished activity in anxiety-related areas, such as the insular cortex and the amygdala. The meditation practice known in Buddhist tradition as compassion and loving kindness fosters an altruistic perspective towards others. Brain regions that fire up when putting oneself in the place of another, the temporoparietal junction, for instance, show an increase in activity. Before the benefits of meditation were widely known in Western society, people were already experiencing the benefits of these practices via the relaxation response. The term relaxation response was coined by Dr. Herbert Benson, professor, author, cardiologist, and founder of Harvard's Mind-Body Medical Institute. The response is defined as your personal ability to encourage your body to release chemicals and brain signals that make your muscles and organs slow down and increase blood flow to the brain. Dr. Benson's book basically took his studies on the benefits of transcendental meditation and demystified it for a Western audience. The relaxation response is a helpful way to turn off fight or flight response and bring the body back to pre-stress levels. Dr. Benson describes the relaxation response as a physical state of deep relaxation, which engages the other parts of our nervous system, the parasympathetic nervous system. Research has shown that regular use of the relaxation response can help any health problem that is caused or exacerbated by chronic stress. Exercise is also very important in brainwave maintenance. Exercise alters brain chemistry by increasing dopamine, norepinephrine, and serotonin. These chemicals are produced during the alpha and theta states. Tai Chi and yoga exercise studies demonstrate numerous benefits: increased relaxation, including decreased anxiety, a trend for increased EEG activity in the theta and alpha ranges, and reductions in depression, anxiety, and sleep disturbances. Although exercise is considered a form of stress, it seems that what makes exercise-induced stress different from stress due to negative life events is that, in contrast to psychological or bad stress, physical or good stress is associated with increased inactivation of the stress hormone cortisol into cortisone, which is in its inert form, and increased brain levels of the fatty acid AEA, brain-derived neurotrophic factor, and serotonin. In particular, it seems that aerobic exercise modulates hormone, neurotrophin, and neurotransmitter levels. Yoga and aerobic exercises bring about a rise in the levels of dopamine, GABA, and acetylcholine levels, while anaerobic exercises build up the serotonin levels in the brain. Exercise is also shown to play an important role in the learning process, one of the desirable targets for brainwave entrainment. The first positive effect of exercise is an increased oxygen flow to the bloodstream. Aerobic exercise has been shown to pump more blood throughout the body, including the brain. More blood means more oxygen, which increases capillary health and the growth and plasticity of the frontal lobes. A second physical benefit comes from the release of protein IGF-1, which triggers the release of brain-derived neurotrophic factor, BDNF, which in turn stimulates neural growth and learning, and this has been called Miracle Grow for the brain. So you don't have to put Miracle Grow on your brain. Studies have shown that exercise enhances student learning and positively affects emotional and physical well-being. Research also shows that we continue to grow new neurons throughout our lives. Therefore, a third and perhaps most important benefit of exercise is neurogenesis. One of the places in the brain neurogenesis has been found is in the hippocampus, which is involved in the storage, consolidation, and retrieval of information. Research has also shown that exercise plays a role in the generation of new cells in this structure. And biofeedback. In the 1940s, psychologists and other researchers began to investigate artificial ways of giving people feedback about otherwise hard-to-monitor states. For example, they developed machines that picked up electrical signals from muscles and converted these signals to lights, visible signals that might reflect the degree to which a person was unknowingly tensing up his or her muscles. It was a short step from here to see if people could learn to alter these signals and thus change their own physical or mental states in desirable ways. Researchers eventually created the term biofeedback to refer to procedures that allow people to monitor their physical and/or mental states and train themselves to change these states. Neurofeedback is the term for biofeedback that gives people feedback about their own brainwaves. Neurofeedback devices collect information via EEG, galvanic skin response, and heart, pulse, and breath rate monitors. These devices measure stress and relaxation parameters and then play back the signals to the user so they can use the signals as a beacon to guide and steer themselves into a relaxed state. These have increasingly incorporated the use of video feedback and gamification. There has also been a growing consumer market for these devices. Check out Amazon when you get home. Two other elements that are not necessarily brainwave entrainment methods, but which are foundational to the functioning of the brain, are diet and sleep. The food we eat directly affects the efficiency of the neurotransmitters in our brains. Nearly all of the brain's neurotransmitters are composed of amino acids. We obtain amino acids from the food we eat, so it makes sense that what we eat affects the amount and efficiency of these brain chemicals. The amino acid tryptophan, synthesized from carbohydrates, is used to produce serotonin, a neurotransmitter that creates feelings of well-being and calmness. Tyrosine, an amino acid found in proteins, is used to make dopamine, a natural stimulant. Amino acids are also used to protect DNA and brain cell components from damage. The quality of the food we are eating also matters. Recent findings have also confirmed the benefits of highly unsaturated fats, commonly referred to as omega-3 fatty acids. These fatty acids, found in cold water fish, flax seeds, eggs, and certain meats, are crucial for hormonal balance and the immune system, both of which are essential for a healthy brain. Studies in animals have shown that diets without omega-3 fatty acids lead to learning and motor problems and may affect systems that use dopamine and serotonin in the frontal cortex. And sleep. Quality sleep and getting enough of it at the right times is essential. Without sleep, you can't form or maintain the pathways in your brain that let you learn and create new memories, and it's harder to concentrate and respond quickly. Sleep is important to a number of brain functions, including how neurons communicate with each other. In fact, your brain and body stay remarkably active while you sleep. There are periods during the sleep cycle when the brain is as active as when you are awake and solving a problem, which may be exactly what the brain is doing. Some researchers call this the nocturnal aha moments, that we may wake up from a dream and have the answer synthesis of something that we've been working on. Sleep also plays a housekeeping role, removing toxins in your brain that build up when you are awake. Given that sleep is a time when brain cells replenish themselves, and when connections made during the day are strengthened, sleep deprivation can have a major negative effect on brain functioning. So, coming back to the libraries, we've been all around through time and space and science, and we're right back where we started here. Today we've talked about brainwaves and different methods to help get brainwaves to a desired frequency range, and that different brainwave ranges are helpful for different tasks. So this is a diagram that shows different brainwave frequencies, their ranges, and the general characteristics. So this can be a really helpful chart to figure out how to use the different brainwave entrainment ranges to focus on different programs. Brain researcher Ned Herman believes that knowledge of brainwave states enhances a person's ability to make use of the specialized characteristics of those states. These include being mentally productive across a wide range of activities, such as being intensely focused, relaxed, creative, and in restful sleep. So this opens the door for us to offer library programming in a way that leverages these brainwave frequencies, or library classes, events, that leverage these frequencies. Practice. And we're already offering many programs that do this at our branches. I know that many of us already offer meditation, yoga, tai chi, musical programming, study classes, all these different types of things. So one option that we have to use this information that I shared today is to pair these programs with information sessions about brainwaves that explains the benefits of those particular activities. I did this last summer when bringing the Musa Baroque group to my library to play and presenting a brainwave entrainment talk focused on the effects of Baroque music and learning afterwards. Making the program and the presentation directly relevant to each other led to a very engaged audience, and hopefully one that was entrained to relaxed learning. Another option would be to have a guest speaker come talk about the different biofeedback consumer technologies that are currently available. This talk could also include discussion on the plethora of brainwave entrainment videos available online through YouTube and other sites. So having an expert to come in to kind of help people along to find out what is of good quality and what has sound science involved is very important, because this is a very popular field, increasingly so nowadays. So there's lots of varying information out there. There are lots of books out about the brain as well, and having a nonfiction book group highlighting these topics is also an option. We can also utilize brainwave entrainment to make an environment during programs that supports the kind of activities our patrons are doing. If we want to relax with a coloring club, we could be playing alpha brainwave entrainment music in the background. If we want to boost creativity at an art program, we could attune to those brainwaves that are focused in the creativity range. What about hosting classes for training in new skills, from computers to knitting, with the learning entrainment music? How about we use it for after-school crowd control to calm people's senses? I've not looked into the ethics of these, but we could also use these to market and promote our programs that appeal to these specific types of desired outcomes. So if we want to market programs for study programs, study skills, learning, then we can promote the kinds of brainwave entrainment that go along with those programs, as well as relaxation and wellness. Those are just some ideas that I have in my brain, but we all have brains that are generating brainwaves and great ideas right now, so I'm also curious to find out about what you all take back with you and the places that you go with this information. Thank you very much. Oh yeah, and if anyone has any questions, I am happy to answer questions.
I was actually just going to say L-tyrosine is a precursor to adrenaline, which is the concentration thing. So L-tyrosine, which we tend to be very short of in our diets, is one of those important things. We've found a lot of work with kids that have been diagnosed with ADHD and such are actually just tyrosine deficient. And it boosts things up, and it's like 13 to 14 diagnosed forms of ADHD are just tyrosine deficiency. So that's one of those things. And the other thing that's interesting is just as a sort of a acoustician by default in some ways, those hertz ranges, like you're saying, don't listen to those because what's known as weaponized sound is between the hertz of 0.5 up to about 12. And those will actually act as neurodisruptors at a high enough volume, whether you can collapse or you can have seizures.
That is a very good point about this, to practice everything with caution. And I do know that some of these ranges have been used to completely make people lose all control of their bodies. Yeah, I actually had an electronics music professor when I was in college who he and his buddies thought it would be like really great to go into their music hall with the equipment that would be able to play these frequencies because they thought it was a big joke and they had to crawl out of the room. So yes, please take all of this with caution. Maybe stay out of those lower ranges. Work towards optimizing your relaxation, your meditation skills, and your focus. Oh, let's see. So this sound is actually from a file from YouTube, and I first got into the topic of binaural beats when I was working for the Brisbane Library down in San Mateo County, and our system had a box set by a psychoacoustic engineer named Tom Kenyon called The Ultimate Brain. So it had multiple different discs and different brainwave frequency ranges along with a guidebook, and I had not been familiar with this technology previous to that, but as mentioned in my intro, it was one of the first things that I found that could actually help me fall asleep and stay asleep. So I, in my time in research and finding out more about this and doing this presentation at other libraries, I've had other people come up to me to let me know that they have also experienced the benefits of using binaural wave entrainment. Oh yeah, white noise. I don't know too much about that as far as entrainment is concerned, but that does give kind of like a broader range of frequencies in the sonic envelope, so I think that can be soothing to people who want to kind of disperse their focus from the individual sounds in the environment to be kind of like a broader range of sound. And I do know that white noise machines are also used to block sound and speech, especially in environments requiring privacy, like therapists or psychologists' offices. So that's probably another reason why people are able to use that for sleep. Okay. Oh, yes, please.
I was wondering if you've got some of the ASMR videos and newspaper, but like I'm just curious how, because that's such a big, it's just out right now, I guess.
Yeah, that's so ASMR is recorded with the use of binaural microphones, so it's actually more accurate to how you hear than using a single microphone and splitting that sample. And I do know that there has been a push to remove ASMR videos from sites like YouTube for some reason. I think it has to do with its connection to the belief that it is a factor of sex work, which is really not accurate. Yeah, that's also what yeah. But if, I don't know how familiar everyone here is with ASMR, but it's a type of recording where people respond physically to soft touch or very close sound like this. So there are lots of videos you can find online with people talking very close and very silently about this. And it's really important to some people that don't have the ability to have somebody close in their life like that. So that's a little basic. Yeah, so that's another area of research to go into, and I really appreciate all of your questions because, like, I could go on for days about this stuff. I was only able to, like, include some of the copious research I unearthed, but I will be sure to send around links or information with the different sources that I use so that you can follow up on those different scientific studies. Thank you.